Happy review day. On the board is our study guide that, now that I'm looking at it again, I realize there is a very slight issue with. It says there is no slide deck and that is spooky. I think the spookier thing is that there is a slide deck 7. It's just that I split apart prototyping and testing. So it's lying to you. Prototyping is slide deck 6, testing is slide deck 7. Who has questions? I can kind of go page by page through this as well if you don't have something that can easily refer to it. But any questions in preparation for tomorrow's exam?
On the possibility space, there's one that's how do positive and negative feedback loops affect the possibility of space?
Yeah.
From my understanding, it's just more so if you're right, spend in a positive feedback loop. As you go through the possibility space, it gets narrow quicker because the feedback loop is kind of leading in towards one factor.
Toward the end of the game, yeah, with the idea of the decision space is going to be collapsing as the game ends. Yep. If you have a negative feedback loop, then either the game is giving the players in last place some kind of benefit, something that increases their possibility space or gives them the ability to do that. Sure. What else do we see? Anything in there that's worth asking questions about? I guess I can blow this up a little bit. Kind of small. I can start at that top too, since it's a small end as well. So for prototyping and testing, main points of interest there. Why do it? Just being able to justify what is the benefit of paper prototyping. Be able to talk about when it would be a good idea to paper prototype, be able to generate an example of that, generate an example of when making a paper prototype is not the best idea. Knowing the tools you can use. I may have you go through a paper prototype design, something like I give you an idea and say, here's a game idea. How would you paper prototype this? And have you construct the ideas that would be necessary for that. So sub questions of that, things like, what would the map layout look like? How would the AI be making decisions? How would you be ensuring that the AI's decisions are interesting to the player or challenge the player at an appropriate level but are meant to be defeated? How would you design the game objects on paper? How could you collect data to figure out if the rules need to be changed or how would you adapt the rules of an eventual digital game to be played on paper? Then come up with a list of questions during a playtest that would allow you to gain the most useful data. What data would you collect? How would the analysis of that data help you make decisions in the rest of your development? We had the game balance intro, so designing for fairness using math and difficulty progression. We talked about PvP game balance a little bit. So how do you design so that players can utilize multiple viable strategies to win a game? We talked about 3 dials of balance. What is the purpose of spreadsheets for game designers? How can they be useful to us? We have spent a lot of time writing programs and recognizing that we haven't used spreadsheets for a ton in this field. So what should have a program written for it? What should have a spreadsheet designed for it? What are the benefits of writing a program for something, to visualize something or to simulate something? Benefits of using a spreadsheet program for something. So be able to give an example of when using a spreadsheet would be useful or better than writing a program. We talked about the differences in class between the 2d10 and the, what was it, 6d10? D6. It was 2d6 and 10d6. There we go. So differences between given distributions, I might have you look at a mechanic and determine whether it would be better to use one die roll or another die roll, or to suggest how dice could be used to simulate that mechanic and justify why the number of dice and the sides on that dice would lead to an interesting or an outcome that you would want to prescribe for that. Let's see. Using randomizer technologies. So when is it best to randomize something? What should you be aware of when you randomize something? Be able to come up with an example of a particular randomizer. If I give you a game or ask you to give me a game, be able to describe some of its mechanics mathematically. Even if you can't describe the exact underlying formula, you can take a guess at how a particular game's math works underneath the hood based on your experience with it. Yeah, positive and negative feedback systems. Talked about possibility spaces. I may give you a game, I may ask you to give me a game, and then describe its possibility space. I could give you a mechanic or have you give me a mechanic that is deterministic, or that is transitive, or that is complete or incomplete for information. We talked about information completeness and how that affects possibility space. Did look at mechanic symmetry. Talked already about positive and negative feedback loops affecting possibility space. Being able to determine if a game is solvable or not. I may give you a game that you've never heard of or seen before. It's describe its rules. Then you could tell me if it's solvable or not. I could ask you to give me an example of a solvable game or an unsolvable game and justify why. We talked about metagames, which are the players optimizing the given rules and resources that they have to create what decisions turn into the best outcomes. So that leads to a lot of imbalance in games where there are right decisions and wrong decisions, and sometimes that leads to the decisions being less interesting. So if there is metagame imbalance where there are right decisions, what tools do we have as designers to be able to fix that? Questions on anything covered so far? Any further clarifications or anything else? It's pretty straightforward compared to other classes. This is fairly straightforward. We talked about game systems. So the big one in there was time. So being able to link existing game mechanics to their effect on time. Time being used as a meta variable for designing game systems. I may have you design a game system and tie it to time in some capacity, or say, here's the outcome we're trying to receive or we're trying to get out of something. Design a mechanic that utilizes that or utilizes time. Then just what kinds of mechanics work well with time or not so well with time. What currency designs exist for different types of games. Talked about curves, determining appropriate mathematical relationships for progressions in games between game objects or systems. We talked about different relationships, the trade-off relationship. Modifications most likely made to pure mathematical progressions. So things like the changing of the start and end of it, being able to turn it so it does one thing early on and then it becomes another function, so a piecewise function in that regard. So be able to give examples of when a pure function may need to be modified, reasons in games for why you might decide this is still a good fit mathematically for the game as a whole, but it doesn't fit the tutorial, or doesn't fit the end game, or doesn't fit the second half of the game. And last, we talked about anchors. So broadly, what is an anchor? What are the more common anchor mechanics? With an example, be able to identify an anchor, relate other systems to that anchor. So being able to come up with something like, how is MP related to HP? If MP can be used to cast a healing spell, then MP can be converted to HP at some rate. Might give you a system and have you identify imbalanced game objects or justify their imbalance by tying it back to the anchor. This would be something like if I gave you the 1 mana, 2 mana, 3 mana, 4 mana, and 5 mana cost skills and gave you associated damage for those or healing for those, be able to identify which of those are imbalanced or why within a particular context. We talked about comparative anchors. When should comparative anchors be used? Here's a fun one relating back to software engineering. How are system interactions similar to integration testing? That's something we very briefly talked about, but just thinking about different systems that can be designed by different people and they can operate independently when they come together and make a game. It's very much like integration testing, where how those systems interact together hasn't had the ability to be tested. And we talked about granularity, kind of the distance between the numerical level up points. So we talked about this with respect to level curves, where if the experience is so low that there isn't really room in between those mechanics, the downside was that we could only expand on these systems at the end. So we could only give end game expansions. We couldn't make changes to the game in the middle because the granularity was too low. And if the granularity is too high, the numbers kind of lose meaning. People can't easily visualize when there are 8 or 9 or 10 digits floating around on all numbers on the screen. What is the difference between that? It ends up being a logarithmic scale when you add a number to the end of a 9-digit number, and that is not something that people can easily justify. In fact, most players will think that 8 nines is a larger number than 9 ones, just because they see the nines and they think big. They see the ones and they think small, not that 9 digits is more than 8 digits, because when you throw them together, the nines are wider than the ones, and so it just looks like a bigger number, even though it's not. So if granularity is too high, you may end up confusing your players because they can't comparatively think about the numbers that are being presented to them. So all things like that. Is there anything I can answer?
You feel a bit more in depth on like the kinds of mechanics that work with time.
Yeah, mechanics that work with time. What were some examples of that from class, just to query the class? What did we discuss? So the obvious ones are when there's a timer on the screen that the player has to engage with, but time has so much more depth than that. Time is almost always a factor in a gameplay system. And it doesn't have to be readily apparent to the player. What were some examples of that? Yeah.
The mana costs.
Yeah. So how does mana cost affect time?
Well, if you want to spend, disproportionate amount of mana on attacking this more damage, it might not make sense from that perspective. But if it saves you more time and kill more monsters, that's what the actual cost is.
Yeah. It's not how likely are you to win this fight. It may be how much currency can you gain in the next hour of real world time. If you're a child with their parents saying in 1 hour you need to be doing something else, as a child you're thinking, how much resource can I gain in that 1 hour? How many enemies can I defeat in that 1 hour? In which case time is a factor in the decisions that they make in your game. Sure. What else? Let's go 1 then 2.
Mechanics that work with like literal travel movement, so if you have fast travel or if you have mounts or something.
Yeah, movement speed or teleportation through areas can certainly affect time. A game that doesn't have a fast travel system, like Morrowind didn't have a great fast travel system for much of the game, you end up needing to make decisions based on the actual proximity of location to location. Regardless of what might be better for you or worse for you, that means that you're going to be handling quests in batches in those areas before you decide to move on to the next area. You're going to be... It changes how you explore. There's more unknown up here than there was up here. Maybe I should go up there first because it's going to be hard to go up here later. Yeah, I was going to go here first, so 1 then 2.
For action and fighting games, the cooldown time for a weapon relative to the how much damage it does.
Yeah, so especially in Yeah, fighters, MMOs, if there's a cooldown on an ability, then that can be a balancing factor for that, that skill. It's a powerful skill, but you can only use it every 12 seconds. So you don't want to get yourself in the middle of a tough fight, use that, miss with it, and then be stuck on a 12-second cooldown. And that can change how you play that game. Absolutely.
I think we talked about like a lot of mobile games, you have to spend like days waiting for something to build.
Yeah. Yeah, so changing of how frequently or how fast something you decide to build something, when is it available for use? Time can be a factor at that point. And that way your resources are sunk immediately, but the benefits aren't seen for a while. So that can lead players to need to plan around, I won't have the resources that I would have had available while this thing is under construction. Sure. Yeah.
The day-night cycle relative to like actual time, because like in Minecraft, it's
Yeah.
12 minutes, but in Animal Crossing, it's like whatever time it actually is the time of the game. Like you have to wait for actual night in real life for it to be night in Animal Crossing.
Yeah. Yeah. And similarly, if there is something like a day-night cycle, like we can use Terraria as an example, things are more dangerous at night than it is during the day. So how the player spends day planning for night and spends night trying to survive, there creates a kind of like exercise where you push yourself and then take a bit of a break, push yourself, take a bit of a break. You don't have to hone in and be thinking strategically all the time, like trying to survive, but it creates a cycle for the player's decisions based on a level of cycling difficulty within, hopefully, that flow state still, but it cycles within the flow state to make you feel powerful and then fighting for your life, and then powerful and then fighting for your life. All of those are great examples. Any others? Can be very useful in upgrade systems where the upgrade just makes things take less time. And that way you're not getting more powerful by just the raw damage output, but you can do the things that are powerful more frequently. Or you can move faster, or you can, and it changes how you play, how the world seems. When you're new playing and you can't move very fast, the world seems very large. But at the end of the game, when you can fly or you can move around the map very quickly, it starts to feel much smaller and like you've conquered the map, the mechanics, something of the sort. Yeah.
We talked about tutorial times, how long the players are in the game.
Sure. Yeah, so the length of a tutorial is that absolutely. We talked about players spending their time in your game, making sure that you're spacing their rewards in such a way that they're consistently feeling rewarded for engaging with playing your game. If too long is between those rewards, they may decide to give up, put it down, play something else that rewards them better. All sorts of things you could attach yourself to. Other questions?
How dissimilar is this exam going to be from the first one we took?
Between not dissimilar at all and very dissimilar.
Okay. Like kind of the same type of style. Fairly similar. There will be some questions that will query your understanding fairly directly, and there will be some questions that are more open-ended and having you supply a lot of your thought process and tie your thought process to what we've talked about. This class is actually very difficult to write exams for because game design is the most creative outlet within computer science. So I don't like writing exams that are just, can you regurgitate information from class? Or can you tie this even to games that you've played? I want to put you in the designer's shoes and have you working on something where it's tough to grade at that point because I'm just looking for, is this design intelligent and using these ideas? That's tough to be able to say yes or no to because it's just my opinion of that idea. But I can try to have you tying those directly back to these ideas where possible. So do you understand the idea through using your creativity to incorporate it into something that you think is fun or cool? That's typically how I try to design these. Oftentimes, I'm not looking for an answer. I'm just looking for your process and for a process to incorporate these ideas. What else?
I'd be kind of interested in talking about solvability, like.
Yeah.
Just like determining if a game that you, like, I mean, we already know. Pretty common knowledge about tic-tac-toe, so.
Yeah.
But like, how would we go about thinking about something that isn't solvable? Or that is solvable? How do we go about taking something we don't know if it's solvable and trying to determine if it is solvable?
Yeah. So a lot of the time, that's a very theoretical question. If something is not particularly solvable, or if it is not solvable, to the average player, it's going to feel fairly equivalent. You sit down to play chess, which is solvable, and to the average human, it feels unsolvable. Your experience relates to the next game, and then you learn some basic concepts about the game, some things that work, some things that don't, contextually. But it wouldn't matter if we were playing something that had a significantly higher possibility space or an infinite possibility space from there, because we're just past the realm of what a human brain can optimize. So that's one way to think about it. But on the other hand, it is also useful to think about, can a computer solve this game? Is there a way for us to derive an algorithm that would eventually be able to solve this game, even if it would take a very long time to do?
Can you use like a handful of examples for like each one?
For solvability?
Yeah.
Yeah. So let's query the class. What's a game that's simple and solvable?
Tic-tac-toe.
Tic-tac-toe is a great example. We've taught chickens how to play tic-tac-toe. There's just about anybody can read an algorithm on how to play tic-tac-toe optimally and then play tic-tac-toe optimally. Some people will figure it out on their own. Some people can go look it up and then, all right, there is a way to play this. There's an optimal way to play. And if your opponent is also playing optimally, you tie. There is no way to lose tic-tac-toe if you play optimally. Why? What makes it a kind of trivially solvable game?
Overall complexities.
Yeah, what would that break down into? What are the components of the game's complexity?
Words, choices.
Choices, so kind of like the branching factor. I like to think of tic-tac-toe as a tree. For the first move of the game, how many places are there for you to move?
9.
9. Your opponent gets to move in how many places?
8.
8, and then 7, and then 6, and then 5, and the game might be over at that point. Who knows? But there's an upper bound to the limit of how many possible game states there are, and it's relatively few comparative to a lot of other games that are out there.
Oh, I was gonna say,
Yeah.
what's that? I don't know if it counts, but what's that game where it's like you have 21 marbles, you take turns removing
And column.
what?
And column.
And column? Yeah, it's like, that game where it's like 21 marbles.
Yeah,
you
I think
take
that's one
and
column.
three, and you lose if you take the last one.
Mm-hmm.
Like, is that solvable?
Trying to think if I can fully remember the rules to that, but
I think that's a different game.
yeah, if there's randomization in there, then it's still solvable, but it's solvable in its expectation. That means that you may be making what looks like suboptimal moves in hindsight, but when you're looking forward, you're trying to understand what are all the possible outcomes. If you're interested in looking at that, I actually would recommend that you take my Cyber 480, 580 class in the fall, where we look at a lot of this style of question of how do you break something like this down into it, because AI is just search. It's complicated search. And so solving a lot of games, I bring a lot of games to that class as a how do you search through a game space if there are questions on how do you handle that probabilistically. Actually, part 2 of game dev will also handle that a little bit in terms of the optimization of AI in that respect. But yeah, you can optimize things moving forward, but then once they actually happen, it might not look like it was a great decision in hindsight. So if there are probabilistic moves, if there aren't probabilistic moves, what is the branching factor? What is the depth? How does that relate? Yeah.
So would a game like a card game like Uno be unsolvable, or would it be solvable?
It's unsolvable because we don't know what the other people have.
Okay.
But in the sense of, I don't know, maybe probabilistically, we could come up with something probabilistic that says, here are the cards that are in the associated state space. We know the rest of the cards that are in other people's hands and the deck. Based on that, if I play a particular card, how likely is it that the next player has something that can play off of that? So I think you might actually be able to make that reasonably solvable in terms of how to play optimally given that information.
Well, that's the thing is like, is the solvability mean like a guaranteed win, or is it just like breaking down the probability to like your most
I think
likely?
it deals with hidden information and how quantifiable is that hidden information. If the probabilities are apparent, then I would state that the game is solvable because you know what the optimal move is. Even if that might not be the best move, it's the hidden information that made it not the best move. And that's tough. I think we were here 1 and 2.
Just thinking about it a little bit, I feel like there's also like a fair amount of like different. In my mind, it seems like there might be 2 different kinds of solvability, like
Yeah.
a game state solvability, like what's the best move for the state, and then what's a best move overall. Because in certain, especially like in chess, there are certain situations where doing a suboptimal move might be help you to make a more optimal move further down the road.
Absolutely. In fact, chess is it's a very interesting game to study. So one way that you can try to solve chess is that you put a horizon out there. You say, I'm going to look up to 6 moves in advance. I'm going to figure out how can I make the best move now that puts me in the best position 6 moves from now. The issue with that is you can look really good 6 moves from now, and the 7th move is your opponent capturing your queen in a way that is just, it's straight up terrible for you. So regardless of where your horizon is, it's not far enough out. Or there's the ability for it to be a mirage in terms of how good that move looks based on the limitations that you're placing on yourself. So in that case, it wouldn't be solvable because you're using a non-game end state as a heuristic for the game's your position within the game.
I know, like, to a certain extent, I think chess, like with computers and algorithms, they've figured out every single possible game state up to 4 moves away from checkmate. Like anything that has like 4 games to like 4 moves to the end of the game.
Yeah.
But that's saying something if you can put like a giant supercomputer on this problem and you can only see 5 moves in advance for a complete game in chess. And that's all you can figure out with
We've gotten past that by a bit since that was done. But yeah, no, it's still optimal chess solving engines can still look out about 7 moves, 8. So that's about it.
Nice. So when you're talking about solvability, are you assuming that like you don't have access to the hidden information? So if like you're talking about
Right.
You don't have access to other people's hands and that kind of information to figure out strategies.
You can still use a probabilistic analysis that says we've been playing for, I don't know, 4 revolutions. We've been on yellow, 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 yellow. All of the cards that have been played so far have been yellow. If I play another yellow card, the only way that someone can play on top of that is going to be to play the same number. Whereas if we've been playing the same number, and we have more blue than we have red, and you have 2 reasonable options here, a blue and a red, you would be people would draw more frequently if you play the blue than if you play the red.
So you can kind of deduce hidden information, but you don't actually have access.
Right, you don't know what's in hand, but you can come up with probabilistic estimates based on the common information about the board state.
Okay.
So to me, that's still not perfect solvability, but you can still act intelligently. Whereas I'll use Magic the Gathering as an example. Again, you sit down with someone and you have no idea what their deck is. Absolutely no idea what cards are in there. How can you play optimally to counteract what you don't know is coming? It's completely unknown. So you can't even figure out what chances you have to win. You have to go based off of limited information. You're playing based on your own options and not their options at all. That game is not solvable just because you can't You cannot anticipate, you cannot assign probabilities. You don't have the information. There are still optimal moves you can make with that hidden information. Given the information that you have, but it's not something that you've considered or built into your decision making. I think that's the big difference maker.
So like, if we had to just, kind of break it down a little bit, what are like some common mechanics that would make something unsolved? Like we had already discussed not knowing somebody's.
Yeah, something that is completely hidden and you cannot estimate the probabilities of. Basically, if the system is unknown to you, that is unsolvable. But in fact, there are still things we can do about it, and that's something we'll talk about next quarter. Well, how do you learn through experience to be able to estimate those probabilities?
But here on I'm looking at the solvability slide right now.
Yeah.
I think I may have missed this day, but it said like, is blackjack solvable? And that's kind of the same thing as what we were talking about.
Yeah, so that limited solvability.
Yeah.
It's not that we can always move toward, you can count cards and you can use knowledge of how likely it is that you're going to bust on a hit versus a stay, and how likely an opponent is going to bust if they hit or stay, especially since the opponent's algorithm is known. The opponent doesn't have a chance. The house doesn't get to choose whether they hit or stay. There's an algorithm dictating what they do.
So I guess like the main lesson would be like probability doesn't equal solvability.
Right.
Yeah.
Yeah, but you can still utilize the probability to make informed decisions.
Talking about blackjack, I knew a math major who graduated a couple years ago, and he did like his senior project on blackjack, and he figured out a way to solve it, but you have to play like 700,000 times to ensure that you're making more than you're losing. So that way it's solvable, but nobody's gonna ever play 700,000 blackjack.
We can actually show. I'll show the reinforcement learning algorithm that you can use to solve blackjack.
Oh, there is
to optimize your play at blackjack. Yeah, it just comes from Monte Carlo experience. You simulate over and over and over and over again, and use that information to build a decision algorithm that tells you what to do in every possible state that you could be in blackjack. Yeah, that is cool. What else? What other questions? Go back and do a little bit of lecture, maybe, if there's nothing else. You're like, crap, now I gotta find a question. We don't want that.
Well, I mean, I'm just like, for me, it's just like worth discussing the topic of possibility space. Like, I think that's kind of a transient topic kind of in general, and it's nice to like get some locked down, especially for
sure.
Exam.
What follow-up could we have on that? What do you want to discuss?
Let's see, there was one I had that I've lost now. Oh, it was I had two different tabs open, one for possibility space, and I opened it again and went down to the game, went down to the solvability, and that was the question from possibility space. So I got confused.
I think the easy way to see this, I'll briefly introduce some reinforcement learning concepts because I think that might help here just to understand possibility space. In reinforcement learning, there's an agent. An agent queries the world, basically, uses its percepts to figure out what state is it in. Based on that state, it's aware of some number of actions that it can take. And a state action pair leads to a new state because that action has an effect on that state, and it comes back around, and based on that, you get new percepts to query the new state of the world and some kind of reward based on the change that you experience. So breaking this down into a game, you can imagine something like a turn-based game where we could start with something like tic-tac-toe, where originally the state is just the board. You have the board, there's nothing on the board. There are no X's, there are no O's. We care about whose turn it is. So it's X's turn and there's nothing on the board. That is the state. The action space at this point are the locations that you can place that X, the 9 possible locations. And that creates a new state because where you place that X, your opponent will place an O somewhere, return to you the ability to make an action. Once there's an X and an O on the board, you're responsible for the X, your opponent is responsible for the O, then you find yourself in a new state with a new action space. You can't place an X where there's already an X or an O, but now you're ready to play the next move. And how that, you can ask yourself questions like, is that state space finite? Is that action space finite? How does the state action function work? How do you derive the next state from the previous state? And how do you determine things like a probability of winning? Because that ends up being your reward. If I place an X in a bad location and my opponent places an O in a good location, I am now behind. I have less than a 50% chance to win the game, so the reward that I get for the action that I took should be negative. And I can use that negative reward to learn about what is a good action and a bad action if I can figure out some kind of correlation between the actions that I place and whether I win the game or lose the game. And that can start to simulate my chances of winning the game and losing the game after I've collected enough information.
Maybe it's just because the algorithms, I mean, compilers is fresh off the mind.
Yeah.
But how do you feel about thinking about possibility space as like a state machine? Meaning like,
It makes more sense in a reinforcement learning context than in a compiler's context, but it basically is kind of, it is basically a state machine, but it can be a state machine that flows in one direction. So
Right.
there's not necessarily a loop, or the loop is the end of the game. You loop back around to the start of the game.
Right.
But yeah, that's basically states and actions. It is a directed graph.
Yeah.
And your states are your vertices, your actions are your edges, and you end up in a new vertex whenever you decide to take an edge from a given vertex. So thinking about games, how many vertices are there in that game? How many edges are there between them? Is there a probabilistic state in between that? So when I play an X or an O in tic-tac-toe and my opponent plays an O, that's not a decision point for me. By the time I get to decide again, my opponent has made a probabilistic move. So there's a chance node there that I don't get to interact with, but splits the probability. If I place an X in the top left corner, I'm thinking about all possibilities where my opponent places an O in all of the other 8 spaces before it comes back to me, but I don't get to know that when I place that first X. So that's where a probabilistic model comes in. When I place this X here, how likely is my opponent to place an O in each of the remaining 8 spaces?
so like, I like to think about the idea, like if it was a state machine, if there was some kind of loop table in a particular game state, and there was 6,000 possibilities, that would just be 6,000 more edges from going from exit edges from that state.
Sure.
Yeah.
But it is finite. But is it a decision point? Sometimes that's a chance node. You do something, you kill an enemy, and there are 6,000 different combinations of what could drop from that enemy. Now, that's a chance node. You have to you decide, kill the enemy or not kill the enemy, based on the expectation of this chance node of what you might get.
What did you say when I first said thinking about it like a state machine? You said you had to reply.
Yeah, thinking about it more as a graph. And a state machine is just a graph, but kind of abstracting from the idea of a state machine and just thinking about it as a directed graph. An edge between 2 nodes in that case is just an action that leads from one state to the next state. And the fun discussion that we're going to have next quarter is that we are in fact all reinforcement learning agents.
Reinforcement learning, I wasn't sure.
Yeah. I have some books for you to read if you're interested in that topic, but we'll dive into it in a lot more detail next quarter. Because a lot of game AI is just reinforcement learning.
Could we pick a mechanic and go through all like the mechanics of possibility space?
Yeah.
Stuff, just to further practical application.
Yeah. Who wants to give me a mechanic?
We're still like on the possibility space topic.
We're gonna do, I think is it deterministic? Is it transitive? Is it symmetric? Is the information about it complete or incomplete?
Roll a die for that many spaces.
Roll a die, move that many spaces. All right. Is it deterministic?
No. Because you can never know what's on the die, what's gonna happen on the die, so you can never plan for that.
Right.
You can only plan for the odds.
Mhm. All right, so it's not deterministic. Is it transitive? I guess we kind of need three things in order for things to be transitive. If this is better than that, and that is better than the other thing, is this better than the other thing? There's not really a concept of better. So not really easy to determine transitivity. But is information complete or incomplete? We'd need to know more about the game, I think, to be able to make that decision.
Maybe we should do
If
this.
this is snakes and ladders and you're rolling and moving, then information is complete because you know the die that you're rolling, you know how many sides are on the die. And when you do roll a particular value, you can plan ahead and see what is going to happen. If I roll 2 spaces and move ahead 2 spaces, this is where I will be. If I roll a 4 and move and there's a ladder there, then I know where I will end up. So there's no hidden information in that case. Let's see. Is it symmetric? It's like, what was symmetric?
Yeah, I think it would be symmetric
How so?
because both players start in the same state. And
Yeah,
it's
so given a mechanic, it's just that, yeah, everyone's rolling the same die. It's not like one player is rolling a D8, the other is rolling a D6. The fact that both players do the same action.
So would it be symmetric if it was like a single player game? Or, like a PBS?
Symmetric is hard to define on single player. I find usually if it's going to be symmetric, yeah, it needs some way of comparing it to some other action space.
Would have the same odds to lose as you have to win. It's symmetric.
Not really. It's a good idea though. It doesn't quite work. Yeah.
What about like,
There was something back to. Let's go here and then I'll go back here.
sorry,
Forget about what you did.
what about like if, so in Bloodborne, there are these fights where you fight basically like another hunter like you.
Yeah.
And even though an AI is controlling it, or like I guess the algorithm is controlling it, it still, you can put on all the same gear as it. And it's not reading your inputs or anything. So would that be symmetric?
That's closer to reasonably symmetric. It doesn't really matter whether it's an AI or another player. You can imagine that is now another player, but it has the same abilities, the same space as you. So it's symmetric in that regard.
Okay, so that makes the mechanic symmetric. But if the game is that mechanic, does that make the game symmetric? Because
If that is the only mechanic in the game?
rolling, so technically they haven't been.
Right. Yeah, they would have to be done in parallel, because the game is not symmetric if one player starts first.
But the mechanic would be that there's symmetric for the rolling and the moving.
Yeah, it's like if they're rolling, then it's equivalent. But yeah, it's not the entire game because we have to decide who goes first. It'd be more fun if they were rolling at the same time and there was a tie than if both players reached the end of the same turn.
I'm assuming like, I guess with a lot of this discussion, it seems that like, for like mechanics determining like whether they are something or like possibilities for it being solvable. I'm assuming on the exam, a lot of it will also be kind of how much reasoning can you put behind it? Like, 'cause for the solvability, right? It seems like a lot of them you could argue both ways. Or like some would be deterministic is dependent on the game around it. So depending on like how much information you give or how much like we're providing will probably be more important than like strictly one way or the other.
Yeah, you'd want to make sure that you're providing the appropriate context to be able to justify the answer that you have.
Because yeah, without context, it seems like a lot of them are very much dependent on the context. Like they just are,
Yeah.
so you could kind of argue either way for a lot of them.
Yeah. Yeah, a lot of the mechanics are going to incorporate other mechanics in some capacity, and if you're zoomed in this far and don't have an understanding of the context around it, it becomes ambiguous. So if I'm asking you to give an example of something on an exam, make sure that you give enough of the context to where I can see why you're arguing what you are.
But like also if you were to give us like a mechanic, let's say is this, deterministic, it might be, it could be true or false depending
Right,
on what other
depending on your
context is.
reasoning.
Well, it would be deterministic if this is how the game goes.
Yeah. Yep. So hopefully I give you enough to make a right answer or a wrong answer, but you give me a reasonable argument and why that context is missing, you may very well get full credit because there's no holes in your logic.
So on the slide deck on the slide for symmetry, talked about like a 2-player PvP FPS being symmetric.
Yeah.
Thinking about like the map, right? If the map was like actually symmetric, would it have to be actually symmetric, or would the side have to have this many 2 lookout spots? The side also has 2 lookout spots, same distance from the start, but they're not actually like mirror images of one.
Right. Yeah, they can be symmetric without being mathematically symmetric, but it shouldn't give one side an advantage over the other for some reason. And that's very difficult to justify in one space or another. If there are 2 vantage points, great, but one of them's turned off the map. Not symmetric anymore because it doesn't give you any information. Yes, they both have 2 lookout towers, but they're not equivalent to each other in the information they provide.
Counter-Strike kind of solves that by having the team switch sides happening again.
Yeah. And that can absolutely work. If one side does have an advantage, then give the other side the equal advantage at some point. Sure. And turn something that is non-symmetric into something that is symmetric.
That's how you break them. Just thinking that it's symmetric. When it's really not symmetric.
In football, the coin flip of whether you kick or receive depends on where the wind is going to blow between now and then. You can figure out how to control the weather, swap the wind direction. You get an advantage, so that's not fully symmetric.
If you're going that granular than nothing, like even if you like have ball player hero, one character is a different color, that color will be easier to see.
Yeah.
So,
Yeah, you would want to point out something like at that fine level of detail, it's very difficult to prescribe something that is perfectly symmetric. A lot of games are close to symmetric, but not perfectly symmetric, and that might be okay. But just being able to note the differences and why that might create an advantage for one side or the other. Anything else with the last minute of class? What do we have?
I had kind of a quick question.
Yeah.
Maybe not quick. This could be, like the mindset behind looking for an anchor. Just thinking about that, like in a game where the anchor isn't as obvious as HP, like the thought process that you might go through to kind of sort that.
What's an example? If you're thinking of a game where the anchor is not HP.
I'm struggling to think of one.
It's challenging. But if you can think of the mechanic that is the building block for every other mechanic, it directly or indirectly ties back to that mechanic, directly or indirectly influences that mechanic, then that mechanic is what you should use as your anchor. Just think of what is the center. You think of any mechanic in the game, how does it tie back to what is it related to? What are those related to? What are those related to? And try to find the most central point, the most central mechanic where everything as quickly as possible can indirectly be tied back to that point.
So like, sorry. So like I'm thinking chess.
Mhm.
The anchor, even though there's no HP in chess, you still would think that the anchor is still the HP in the sense that the anchor is the king. That'd be like
Or the number of pieces that you have
the
available
number of pieces.
and multiplied by the value of those pieces comparatively. But that's even then not perfect, at least in terms of a chance of victory, because there's board position, but you can tying mechanics back to that in terms of the HP relative to how close are you to running out of pieces. Yeah, chess is tough. All right, I'll see you tomorrow for the exam. I'll be in my office for a while if you have questions.
If I hear other class after this.